Hi students, welcome back. In today's video, we'll be learning how to find equations of a straight line. This will be the last assignment from chapter 4, coordinate geometry. The questions we'll be doing are from exercise 4C. Right, before we actually go into solving the questions from exercise 4C, let's look at some of the concepts that we need to revise, such as what is needed to find the equations of a straight line. Yes, the general form of a straight line is in the form y equals to mx plus c. And do you remember what m represents? M will represent the gradient of the line segment connecting two points. Supposing your 2 points are point A, where we label the x coordinate as x2, the y coordinate as y2, and another point where we label the x coordinate as x1 and the y coordinate as y1, then the gradient of the line segment connecting these 2 points will be y2 minus y1 over x2 minus x1. Then what does the letter C represent? The letter C represents the y-intercept value. And how do you find the y-intercept value? It is the y-coordinates value. When you substitute x equals to 0 into your y equals to mx plus c. So if you're going to represent it using your Cartesian plane, right, C is just the value that lies on the y-axis as indicated on the screen. And this particular point will be 0, C. Right, so if you have, for example, if you have an equation that is y equals to 2x plus c, and if you substitute, 2x plus 3, let's say, and if you substitute x equals to 0, y will be 3. And this y equals to 3, this 3 will represent the value for c. That means the point will be 0, 3 on the y-axis. Right, so every line is unique. But does every line conform into y equals to mx plus c? Meaning, does every line have a gradient? Let's look at a horizontal line. What do you think will be the gradient of a horizontal line? Right, a horizontal line does not have any height. That means there's no rise at all. So you're using, that means the value for rise is the 0. And if you to recall how we find the gradients of a line segment, the gradient of a line segment is equals to y2 minus y1 over x2 minus x1. So if y2 minus y1 represent the value for the rise, in this case which is 0, over a certain values for your x2 minus x1, you still end up getting 0, right? So a horizontal line will have 0 gradient. And in this case here, if you're going to substitute m to be 0, then the equations of a horizontal line will be just the y-coordinates. So supposing here, this line here, the y-coordinates of this line, supposing it's -3, then the equations of this horizontal line will just be y equals to -3. So your line y equals to -3 can move along the y-axis, and the equations will just be y equals to the value on the y-axis. And supposing if this value here, it's 4, then the equations of this straight line will just be y equals to 4. Right, so now let's look at what happens if you have a vertical line. Right, so if you have a vertical line, right, let's go back to the formula to find gradients of any line segment, which is y2 minus y1 over x2 minus x1. For a vertical line, you will see that there is no rand. That means there's no value for x2 minus x1. But you do have a height. So anything that's divided by 0 is something that's called undefined. That means you can't define a value for it. Therefore, a vertical line will have undefined gradient. And since a vertical line has undefined gradient, right, we can't substitute this undefined gradient into y equals to mx plus c, right? It does not make sense. Hence, the equations of a vertical line would just be the value of your x coordinate. So supposing the x coordinate of this vertical line is 3, then the equations of this vertical line will just be x equals to 3. Right. And this line can move along the x-axis. So supposing the line now moves to this side of the x-axis, and supposing this value is -5, then the equations of this vertical line will be x equals to -5. All right. Let's look at some other lines. So what happens if a line that is in this direction? So if you look at the line in this direction, you can see that we do have a values for gradient where we can find using y2 minus y1 over x2 minus x1. And in this case here, we also have a y-intercept value. Supposing I call it, let it be a letter C. So for such a line, then the equations of this line will be y equals to whatever the gradient is times x plus c. So the line can move along and it will still conform into y equals to mx plus c, because there is a value for gradient, there is also a value for y-intercept. Likewise, for a line that is in this direction, it will have a values for gradient, also a value for y-intercept. So for this line, it will conform into y equals to mx plus c. Right, let's look at these questions. We're asked to find the equations of the straight line passes through each of the following pairs of points. So we're given 2 points there, point I and point J. Right, so let's sketch these 2 points. You don't need to be very accurate, but roughly let's know where the 2 points are. So -2, -4 will be on the left-hand side and at the bottom. So let this point be I, which is -2, -4. And for point J will be further down. Yes, it has to be lower than point I. So this will be my point J, which is 1, -7. And we can join these 2 points using a line segment. And we are asked to find the equations of that line segment. And if you were to recall what we have learned earlier, the general form of a straight line equation is y equals to mx plus c, right? So there are 2 things that's needed here, the gradient and the y-intercept value. So for gradient, right, let's label the point first as x1, y1, x2, y2. You can use the letter m, right, to represent gradient and ij as the subscript, okay? And that will gives you, let's write down the formula to find the gradient, which is y2 minus y1 over x2 minus x1. And if you were to substitute your y to be negative 7, and then minus bracket -4 over 1 minus bracket -2. And from here, you can just use your calculator to work out the value. I don't know what's wrong with me today. It seems that I'm having very tongue-tied. All right, -7 minus bracket -4, close bracket over 1 minus bracket -2. Okay, so it gives us -1 is the gradient. Okay, and we are not done yet. Why is it we are not done yet? We need to substitute this value into our y equals to mx plus c, and that we'll get y equals to -1 times x plus c, and that gives you y equals to -x plus c. I'm not just tongue-tied. I also cannot write properly today. Okay, never mind. Right. So the next thing I need to do is I can either use point I or point J to substitute into equation 1 to find the unknown C. So I'm just going to use point J. You can use point I, no problem. Okay, it's just your own preference. So substitute J, which is 1 -7 into 1. And then we'll have a -1, your x is 1. So just negative times 1. Plus c equals to -7. So c will be -7 plus 1, that gives you -6. So therefore, the equations of the straight line would be is y equals to -x minus 6. Okay, that's how you do it. All right, let's look at the next questions. So if you were to remember what we have learned at, I think, slide number 2, right, the different gradients, the different kind of gradients for different lines. All right, if you recall, a vertical line has undefined gradient. Okay, recall or recap. Right, vertical line has undefined gradient. And so therefore, the equations of the vertical line would be y equals to, no, vertical line, sorry, wrong. Vertical line cuts the x-axis. So would be x equals to a. And a is just your x coordinate. Okay? And for horizontal line, has gradient 0, has 0 gradient, or 0 gradient 0, 0 gradient. Okay. And therefore, the equations of the line will be y equals to a. A is the y coordinates value. When your horizontal line cuts the y-axis, that particular value, that particular y coordinate will be your equations of the horizontal line. So if we look at this point here, M end. Right. If you were to do a sketch, if you can't visualize it, I think for coordinate geometry, it's not okay. Never mind. You see, the thing is that every one of us learn differently. Some of us have to learn it by using diagram. For example, me, I can't visualize it in my head. I seriously have to like sketch it out. So if you are looking at MN, right, 80, that means the y coordinate is 0. So it will be probably somewhere here. Wait. This will be M 8, 0. And then negative 9, 0 will be somewhere here. So what we are dealing is a horizontal line. Correct? So for horizontal line, the gradient is 0. And this will be the situation that we are talking about. Horizontal line, gradient 0. So the values will just be your y coordinates value. And if you look at the yellow line, the y coordinate will be 0. So therefore, for part I, the equations of the straight line, this one is 3G, okay? Question 3G, not part I, sorry. So for question 3G, the equations of the straight line joining points M and N is y equals to 0. Okay, right. Now let's look at 3H. Right, so for 3H, we have the point 0, 0. Let's use a different color. Otherwise, there'll be a mixed up. So 0, 0 refers to the origin. So we have O here. 0, 7, probably somewhere here. That means your x coordinate is 0, y coordinate is 7. So the point will lie on the y axis. And if you're going to join both points using a line segment, let's use green color. Okay, look at the line green color. Look at the green line. What kind of line is that? Of course, it's a straight line lah. But is it horizontal? Is it vertical? Yes, it's a vertical line. So what do you understand about vertical line? Yes, vertical line has undefined gradient. And therefore, the equation would just be the x coordinate value. And if you look at the green line, the x coordinate is 0. So therefore, the equations, okay, the equations of the straight line joining, please learn to write proper statement, which is very important. You'll make your presentation neater. Joining O and P is x equals to 0. All right. All right, let's look at the next one. So the next questions, you're given the diagram. All right, you're given a triangle. And the triangle is not an upright one. Doesn't matter. Okay, doesn't matter, but we have 3 indices. Oh my god, vertices. We have point A, point B, and point C. So maybe what we can do is that we're just going to label the point. So point C is 5, 5. Point A, it's 1, 1. Point B, it's 1, 3. All right, so what is it we need to do? Find the area of triangle ABC. So that is easy. We have done this before in exercise 4B, I think. Right, so what we need to do is, I'm going to use this one as the base. Right, so if AB is my base, I need a perpendicular height, right? So the perpendicular height will have to come from point C, because point A and B form the base already. So the perpendicular height must come from point C. So from point C, I'm just going to draw my perpendicular height. Okay, I hope I can draw it as horizontal as possible. Alright, so this value here will be the distance. How much would that be? Let's count. That will be 1 unit, 2 units, 3 units, 4 units. So this will be 4 units, 4U, 4 units. And then your base will be how many units? 1, 2 units. So part one is relatively easy. So the area of triangle will be half times your base, which is 2 units, times your vertical height, which is 4 units. And that gives you 4 units square. Alright, let's look at part 2. Let's use a different color. Make our learning more fun. Right, part 2. Find the gradient of a line passing through B and C. Okay, that's also easy. To find gradients of a line, remember we label the point first as x2, y2, x1, y1. And then the gradients, you can use the letter M to represent gradient, and then BC as your subscript equals to the formula. And that substitute in the values for y2, which is 5, minus y1 is 3 over 5 minus 1. And that gives you 2 over 4. That is half, right? Okay, part 2 is relatively easy also. Let's look at part 3. Let's use purple color. Let's make our learning more colorful. Part 3. Find the equations of a line passing through A and C. A and C. Okay. Actually, the question should be just find the equations of a line passing through B and C lah, since we already found gradient for. Okay, never mind. So find equations of a line. So we need to find gradients of AC. Okay, since I've already labeled point C as x2, y2, right? I'm just going to label point A as x1, y1. We're going to find gradients of AC. So that will be 5 minus 1 over 5 minus 1. Huh? Oh, so gradient equals to 1. Okay, and then we're going to substitute the general form of the equation of a straight line is y equals to mx plus c, right? So therefore, what we get will be y equals to 1x. 1x means 1 times x, so just x only. So plus c. Okay, I'm going to substitute just point A. Easier because the number given is smaller. 1 plus c equals to 1. C equals to 0. Oh, so it passed through the origin. So therefore, equations of the straight line passing through, not passes through, A and C is y equals to x plus 0. But please you don't have to write plus 0, just y equals to x will do. So in other words, if I'm going to extend AC longer, right, you will see that it will pass through here like that. Okay? So the y-intercept value is 0. So y equals to x. Right. All right, let's look at question 9. So we are still dealing with straight line equations, except that if you look at question 9, it's slightly different. There's no diagram given. What we are given here, it's an equation. But this equation is not in the form y equals to mx plus c. It's just jumble up. Okay, jumble up. So for part 1, what we need to do is to make y the subject. So what does it mean by making y the subject? So it means that you have to make y the king. Okay, y on the left hand side can only have the letter y and not any other letters. That means that means it will be something like this, that y equals to blah blah blah. Okay, right. So how do we go about doing it? So if you're going to make y the subjects, obviously we need to move this guy out of the house. In the house, you can only have y. So we have to move x over 3 out first. Okay, so let's do it slowly. So x over 3 is positive x over 3, right? So to move it to the other side means I need to minus x over 3 on both sides, right? I think this is basic, right? Do I need to really... Okay, never mind. Whatever it is, it's always good to revisit the concepts, right? Okay, so it's 1 minus x over 3, but I would prefer to write it as negative x over 3 plus 1. Okay, why is that so? Because if I'm not wrong, if you look at part 2, you're supposed to find the gradient of the line. That means that gives you an idea. You have to write it as y equals to mx plus c. That means the x must come first. You understand what I'm saying? That's the reason why I would prefer to write it as negative x over 3 plus 1 instead of 1 minus x over 3. Okay? Right, then the next thing is that I need to make y the subject, right? There's several ways of doing it. Okay, one quite efficient way is to make y over 2 y. You just have to multiply it with 2 over 1 on both sides of the equations. Remember, because you're dealing with the equations. So whatever you do to whatever operations you carry out on the left hand side, you must also do it on the right hand side. Right. So that will gives you left only y on the left hand side, because this one here will gives you 2y over 2. So 2y over 2 will just be y. So what you're left is only y on the left hand side. Then negative x over 3. Now negative x over 3 is just simply negative 1/3 times x. Right, so it's just simply negative 1/3 times x. So negative 1/3 times 2 will just gives you negative 2/3. Okay, and then 1 times 2. You must remember to multiply with both terms. So negative x over 3 times 2 will gives you negative 2/3 x, and then 1 times 2 will gives you 2. Right, so this is how you do part I, and we have successfully arranged it in the form y equals to mx plus c. So from here, okay, from here we can answer part 2, which is to find the gradient. So the gradient will be the letter, the coefficients of x will be the number, not letter. The number in front of x, the coefficients of x. The number in front of x is called the coefficients of x. So in this case here, the gradient is equals to negative 2/3. All right. Right, part 3. Part 3, it says that find the coordinates of the point at which it cuts the x-axis. Right, so that's something that's important. When a line cuts the x-axis here, what is so peculiar about points on the x-axis? A point must have two coordinates, right? The x and the y coordinates, correct? Every point have two coordinates, x and y. So a point that lies on the x-axis, what's so peculiar about it? Yes, the y coordinate is 0. Okay, so what we're going to do is for part 3, we're going to substitute y equals to 0 into y equals to negative 2/3 x plus 2. And we'll get negative 2/3 x plus 2 equals to 0. Negative 2/3 x is equals to negative 2. So x will be just negative 2 divided by negative 2/3. And that will give you 3. Okay, but 3 is not the answer. As in, it's not complete, because you asked to find the coordinates of the point. So therefore, you have to present your answer as 3, 0. This is then complete. Right, let's look at question 13. Ayo, question 13 got so many parts. 1, 2, 3, 4. All right. Not to worry, not to worry. We just take one part at a time. So let's look at part I first. So we have an equation, and the equations is 5x plus 6y plus 30 equals 0. And we are told that on this line here, okay, this line, that's a particular point called P. And P has x coordinate 3 and y coordinates -1. So what is it that we're supposed to do for part I? You asked to find the coordinates of the point where L, okay, the equation, that line has a name called L, line L. And this line L crosses the x-axis. So remember what we have done earlier on. Points that lies on the x-axis is very peculiar. It's very peculiar because the y coordinates is 0. So what we're going to do is we're going to substitute y equals to 0 into our line L, which is 5x plus 6y plus 30 equals to 0. So we will have 5x plus 6 times 0 plus 30 equals to 0. 5x is equals to -30. X is equals to -6. So therefore, the particular point will be -6, 0. Okay, you have to answer to the question asked. The question asks for the coordinates of the point, so you have to write it in this correct format. All right, so that's part I, right? So don't worry, Dave. Don't be what is the word that I should use? Don't be overwhelmed if you see so many parts. Actually, they are quite manageable. Right, so let's look at part 2. The coordinates of the point of intersections of L and the line x equals to 2. Oh, so that is not difficult also. So what they're trying to say is that this particular line that I've just drawn, I don't know whether it is correct. Oh, the gradient is -5. So I should have drawn it the other way around. Do you know how I know the gradient is negative? Can I leave it to you to think about it? I'm sure you can. I'm sure you can tell me why is it that the gradient is negative. Okay, so what they're trying to say is that this line L, okay, actually will intersect with another line L, another line x equals to 2. So x equals to 2 will be a vertical line. Okay, x equals to 2 is a vertical line. So we have this one, x equals to 2, vertical line. And when these two lines meet, right, this is the point that we're interested in. All right, so I know that this point will have x coordinate 2. Yeah, because that particular point lies on the line x equals to 2, and the line x equals to 2 will have all x coordinates too. So I know that the x coordinate of the particular point is 2. So all I need to do is substitute x equals to 2 into our line L, which is 5x plus 6y plus 30 equals to 0. Don't know why they want to call it L. It's so difficult to pronounce L. Can't you just call it line A, easier to pronounce? Or line B? Okay, never mind. So we substitute x to be 2. So 5 times 2 plus 6y plus 30 equals to 0. That will give us 6y equals to -10 minus 30. That will give us -40 divided by 6. -40 divided by 6. -20 over 3. Alright, you can leave it as a mixed fraction if you want to, which is -6 and 2/3. Alright, so therefore, how to present your answer? It must be point, coordinates of the point. So the x coordinate is 2, the y coordinate is -6 and 2/3. So this is how we do part 2. Alright, let's look at part 3. So part 3, it says that the equations of the line passes, find the equations of the line passing through P. Alright, so the line must pass through P. That means P must be a point on the line and having the same gradient as L. Alright, so I need to go ahead and find the gradients of L. Alright, so how do I do it? So I have to look at the equations, the line L. Alright, so I need to do some manipulations. I need to rewrite this equation. Make y the king. Okay, make y the king. So I have to do some shifting. Okay, let's shift this fellow away first. And then let's shift this. And I'm not done yet because I need to make y not 6y. So I need to divide by 6 throughout. So therefore, y will be negative 5 divided by 6, so negative 5 over 6x. Negative 30 divided by 6 will give you negative 5. Okay, and then if you were to compare this with y equals to mx plus c, we will see that your m is negative 5 over 6. That means the line L has gradient negative 5 over 6, right? So therefore, this equations, this line that we're interested in will have gradient negative 5 over 6. Right, so therefore, the gradient of the line that we're interested in is negative 5 over 6. Okay? And therefore, the equations will be y equals to negative 5 over 6 x plus c. Right, so c is the unknown. C is the value we need to find. And we're very lucky. Why are we very lucky? Because we're told that this line passes through this point P. So we can just substitute P into 1. Right, so negative 5 over 6 times 3 plus c equals to negative 1. Okay, I'm going to leave it to you to find c, which will be just be negative 1 plus, just negative 1 plus 5 over 6 times 3. And that gives you 3 over 2. And so therefore, the equation is y equals to, the gradient is negative 5 over 6 x plus the value that's found for c, 3 over 2. Okay, that's how we can do it for part 3. Alright, let's look at part 4, coming to the end, so don't give up. What color should we use? Okay, dark blue. So it's a bit messy, so I need to like find a space to do part 4. Okay, the equations of the line passing through P and have gradient 0. Hiya. So what we are saying is that the equations of the line will just be y equals to, has gradient 0. Have gradient 0, then what kind of line is that? Have gradient 0. Have gradient 0. Is it a vertical line or horizontal line? Come, ting, ting, ting. Gradient 0. Yes, it's a horizontal line because it has no height. Gradient 0 is a horizontal line. So horizontal line, what will be the equations of horizontal line? Will be just the y coordinates value, right? Right? Horizontal line will just be the y coordinate value. If you cannot remember, please refer to slide number 2. And if that is the case, then that will be just the y coordinates of point P. Right? So therefore, you don't need any working for part 4, isn't it? Isn't it what is the word that I should be using? Isn't it fantastic? We don't need any working. We just need to analyze it, think about it. Right, so since it's the horizontal line, the gradient of a horizontal line will just be the y coordinates value, and hence the y coordinates value of point P is negative 1. So therefore, the equation is just y equals to negative 1. And that's it. That's how we solve question 13. Right, let's look at question 14. We're coming to the end of the exercise soon, so don't give up. Question 14 is the second last question. But if you're very tired, just take a break. Okay, go and drink some Milo or coffee or whatever. Eat an ice cream. All right, just take a break. All right, so we have a straight line L that passes through points A and B. Find the gradients of line L. Ayo, by now we should be very confident how to do it already. Yes, just label the point. This one here, I'm very sure you can score 100 marks. Okay, so A part I, finding gradient. Gradient, you can use the letter M to represent gradient. The subscript will be AB. Formula is y2 minus y1 over x2 minus x1. Alright, so that will be y2 is 12 minus 3 over 3 minus 0. So that will give us 3. Let me verify. Yes, 3. So that's A part I. So A part 2 is relatively easy also. Yeah, this is what I mean. I like this kind of questions because, you know, they're just connected. You see, part I asks you scaffolding, they give finding the gradient. And then part 2 just find equations of the same line and not some other line. Okay, so we're going to substitute gradient to be 3 into your y equals to mx plus c. So the equation is just y equals to 3x plus c. Alright, so I'm just going to use point A. Point A, because one of the coordinate is 0, is easier. So sub point A. But if you don't like it, want to use point B, also go ahead. Right, just be careful with the calculation. So 3 times 0 plus c equals to 3. So c is equals to 3. So therefore, the equations of the line y equals to 3x plus 3. Okay, that's it. All right, let's look at B. Okay, what color should I use? Pink. No, there's no pink here. Okay, brown. Let's look at part B. So we have another line, x equals to 3. It's the line of symmetry of the triangle ABC. Find the coordinates of C. Okay, I really cannot visualize it without drawing it out. Cannot visualize it without drawing it out. That means I need to draw it out lah. So let's start off by drawing out. Not drawing, but just have a sketch. Okay, there's no graph paper, so I can't draw it out. Just sketch it. So point A is 0, 3. So 0 means x coordinate 0. So it lies on the y-axis. So I have a point A here, 0, 3. Point B is 3, 12. So it must be higher than point A. Must be much higher. So I need to draw this lower a bit. Aiyo, why I erase everything off? Okay, never mind. It's alright. So point A is here, 0, 3. Point B will be needs to be higher, right? Yeah, somewhere here, which is 3, 12. All right. So the line x equals to 3 is a line of symmetry. Oh, so x equals to 3. That means this line here. This is line x equals to 3. So this is a line of symmetry. So I'm going to join point A and B with the line segment. I need to form a triangle ABC. So point C will be here, right? Point C will be here. Can't draw it properly. Alright, point C will be somewhere there. Right, so AC is a horizontal line. So if it's a horizontal line, it will have the same y coordinates as point A. So we know that point C will have y coordinates 3. Okay, it must have the same y coordinates as. Okay, so your line of symmetry, so that means this line here is actually a mirror line. This is your mirror line, okay? So the mirror, what's the purpose of a mirror line? It means that this distance here, okay, which is how many units? You see, your point B x coordinate is 3, right? That means from here to here is 3 units, right? So here to here will be 3 units. So that means from the line of symmetry x equals to 3, right? Let's use a different color so that you can see the effects. From here to here must also be 3 units. That is the purpose of a line of symmetry. The line of symmetry is like a mirror line. So the distance of you know, from the line of symmetry would be the same distance as you inside the mirror. I don't know how to explain that. So anyway, so the x coordinate of point C will be 3 plus 3, give you 6. Okay, so part B, the coordinates, therefore, point C will be 6, 3. You can actually draw, sketch it out, okay? Include this diagram in your solution to derive point C to derive the x coordinates of point C to be 6 and the y coordinates to be 3. Okay, so that's how we do question 14. Alright, let's look at the last questions. Right, question 16. Yes, congratulate yourself for having persevered. Right, for having come so far. Right, so question 16, let's look at part I. Find the coordinates of A and B. So what are called what is point A and point B? Alright, so we're given a line L, and this particular line L, right, will cut the x-axis at point A. So let's have a diagram. Let's try to sketch it out. So we have a point A here. Right, what is so special about point A? Point A is a point on the x-axis. Right, so the y coordinates will be 0. And then you have a point B on the y-axis. So what's so special about points on the y-axis? Yes, the x-coordinate will be 0. So you join these 2 points up to form the line segment L. Right, asked to find the coordinates of point I. So basically, we have just managed to come up with the concepts. That is, we're going to substitute x equals to 0 into the line L, which is your 3x plus 4y equals to 24. So that will give you 4y equals to 24. Y will be 24 divided by 4, that will be 6. So therefore, your point B will be 0, 6. This is correct? Let me double check. Yes. So now I can replace the values of y to be 6 here because I already found it. Alright, then for point A, I'm going to substitute let y to be 0 instead. Right, so that will give us 3x equals to 24 because 4 times 0 will be 0. So x will be 8. So now I can replace my, wait, let me write properly first. So point A will be 8, 0. So these are my answer. And I'm going to replace your x now with 8. Alright, so far for part I. How about part 2? So for part 2, what are we supposed to do? The length of the line segment AB, that's pretty easy. You can see that triangle OAB, it's a right angle triangle, so you can just use Pythagoras theorem. If not, you can just use the formula to find length x1, x2. What x1, x2? Why am I talking? x1, y1, x2, y2. So the formula will be, there's a square root there because derived from Pythagoras theorem, right? x2 minus x1 close bracket squared plus open bracket y2 minus y1 squared. Let's do the substitution. So that will be 8 minus your x1, which is 0, bracket squared, plus y2, which will be 0, minus away 6 bracket squared. So that will give you 64 plus 36, 100. Square root 100 will be 10. So 10 units for the length of AB. So that's part 2. Right, so part 3, we're told that the equations of a line OC, where O is the origin and C is a point that is equidistant from the coordinate axis. What does it mean by equidistant from the coordinate axis? That means, okay, let me do a sketch for you. So supposing this is your point C. So if equidistant, that means this distance here, okay, must be the same as this distance. This is what it means. This is what it means by equidistant from the coordinate axis. The coordinate axis refer to the x-axis and the y-axis. Coordinate axis refer to the x and the y-axis. So this is what it means. Okay, this distance is the same as that distance. So what do you think your point C can be? That means the x coordinate, you see, here to here is your y coordinate, right? If I let my y coordinate, let's say, be k, then this distance must be the same as the distance from the y-axis, which is your x coordinate. So that means your point C is just You can let it be k comma k or a comma a or b comma b. Alright, okay, never mind. I will just use another point to demonstrate to you, to explain to you. Let's say this point, let's say I have a point 3 comma 3. What does 3 comma 3 means to you? If you look at the x coordinate 3, that means from here to here. X coordinate 3, here to here 3 unit, right? And the y coordinate is 3, that means from here to here. Wrong. Let's start all over again. Rewind. Let's start with the point 3, 3. Right. So let's drop a line here. So this one will represent your y coordinate, which is 3 units, right? And this will represent your x coordinate, which is also 3 units. So can you see this point 3, 3 is equidistant from both axes? Both of them has 3 units, 3 units. Okay? We don't know what point C is, right? So we cannot call it 3 comma 3 or 2 comma 2 or 4 comma 4, right? 4 comma 4. We don't know the value. We need to go and find the value. So I'm just going to replace it with a variable. I'm just going to call it k comma k. And I need to go and find the values of k. No, don't need to find the values of k, sorry. I need to find the equations of a line. So in other words, okay, let me draw it properly. Okay. So that means I have a point C here where the x coordinate is k, y coordinate is k also. Okay. And then this point here, which is the origin. So I need to find the equations of the line OC. So let's start off by finding the gradient. So the gradient will be easy, right? Your origin is 0, 0. So we can label this as x1, y1, and this as x2, y2. So the formula will, to find gradient will be y2 minus y1, that's k minus 0 over k minus 0. That gives us k over k. And what is k divided by k? That gives you 1, right? Just like 3 divided by 3 is 1, 2 divided by 2 is 1. So k divided by k is just 1, right? So that means the gradient of the line OC is 1. And if you look at the line OC, it actually passes through O, the origin. So if it passes through the origin means the y-intercept value is 0. So therefore, your equations of this line of line OC is y equals to 1 times x, because the gradient is 1, right? So 1 times x is x, and it passes through the origin. So you don't need to put plus 0. So the equations of the line is just y equals to x. Okay, I really hope that you can understand my explanation. If not, then please watch through the video again, or you can PM me. All right, let's look at the last part now. The coordinates of the point C, given that C also lies on the line L. Oh, so if your point C lies on the line L, that means we just need to substitute the point C into L. So we just need to substitute C, what we call it, where we let the x coordinate be k, right? We let the y coordinate be k. We just substitute this particular point into 3x plus 4y equals to 24, and you see what happened. That means my x coordinate is k, y coordinate is k equals to 24. I will have 3k plus 4k, that give me 7k equals to 24. So k will be 24 divided by 7. And that give me 3 and 3 over 7. So therefore your point C will just be 3 over 7, comma 3 over 7. Alright, so that this completes all the questions from exercise 4C. Right, so happy solving.